So in this video we're going to be looking at quartiles, interquartile range and outliers. The data we're using is from a sample of 1,000 pregnancies and it can be downloaded in this file. And we're specifically interested in the gestation durations, which is one of the columns, I guess, within that data set. So if we quickly jump over, this is the data when you open it up, and we're interested in this gestation period for the activity we're about to do. So we have three tasks. The first one is to identify the quartiles, so Q1, Q2 and Q3, and we're told to use the common sense rule in order to do this. The next thing is to figure out the interquartile range, which you can get once you've got the Q1 and Q3. And then finally we're asked to identify if there's any outliers, and we've been given a definition for what an outlier should be for this particular case, and that's related to the interquartile range and also the Q1 and Q3 values. So to start off with, what we're going to do is figure out these quartiles. And if we're going to do this using the common sense rule, what we need to do is figure out what observation numbers would correspond to Q1, Q2 and Q3. So if we start off with, we have 1 to 1,000 in terms of our observations, and if we order them from smallest to the largest, so that means that the first observation would be the smallest value for the gestation period, and then 1,000 would be the largest for the duration of the gestation period. So Q2 here relates to the median, alright, so the middle value when we have them in this order. So if I split this up, the first half of the observations would be observations 1 to 500, and then the second half would be 501 to 1,000. And this is like an even number of observations, which means that we need to take the average of the middle two. So that would be between 500 and 501. So let me just change this over. So that means that Q2 sits here, and it's the average of the 500th and the 501st observations. Alright, so that works that out. We can go back and actually pick up the number in a moment, but I'm going to move on and figure out what Q1 and Q3 would then correspond to. And we can kind of apply the same method. So Q1 is going to be the middle value for the first half of the observations. So if we again divide it like we did here, we should be able to figure out where that lies. So the first half of the observations here would be 1 to 250, and the second half would be from 250 to 500. So again, we've got an even number in 500, which means that we're going to have to take the average of the, this should be 251, sorry. We're going to have to take the average of the two middle observations. So that means here, Q1 is going to be the average of 250 and the 251st observation. Now again, we can work out Q3 using the same method. So this is the second half of the observations, and Q3 is the middle value in this range. So the first half would be from 501 up to 750, and then the second half here would be the 751st observation up to 1,000. Alright, so now again it's an even number of observations. There's 500 in total here. So that means that Q3 is going to have to be the average of these two. So 750 and 751st. Alright, so knowing all of this, we can now jump back to our Excel spreadsheet, and let's start by figuring out what the average of the 500th and 501st observations are. So there's a couple of ways you can do this. I'm going to make it easier for us by copying just this column that we're interested in into a new sheet. And what we need to do is make sure that these are sorted in order. So you can do that by going into the Data tab up here and then clicking Sort. I want to sort my gestation days based on the value of them, and I want to go from smallest to largest. So it's defaulted to exactly what I want to do. So if I click OK, it's going to have put the smallest ones at the beginning and the largest ones at the end that you can see here. and we have 1,000 observations. This is row 1001 just because the first row is a title, I guess. Alright, so let's delete this title now that everything's in order, and we should be able to sort through and just figure out what the 500th and 501st observations are. Alright, so that's this here. So this corresponds to Q2, so we need to take the average of these. Now since they're exactly the same value, the average of them is just going to be 279. Alright, so let's jump over and record that value. So Q2 is 279 days. So the next one we'll work on getting is Q1, alright, which we've decided is the average of the 250th and 251st observation. So over to our data. Alright, again it's in order from the first down to the 1000th. And we're interested in 250 and 251. So that's these two here. Right, we need the average of them, but since they're both 271, the average is going to be 271. So again, let's jump over and record that. So Q1 is 271 days. Alright, so the last one that we need is Q3, and that's the average of the 750th and 751st observations. So again, back to our data, which is sorted in order. Scrolling down. Alright, here we go. So we've got the 750th and 51st. Again, conveniently, they're the same number, so when you take the average, it's just going to be 285 again. So that's going to be Q3. So that's our 3 answers for part 1 of this question. Just be aware that what we've just done here was the common sense rule. There are other ways of calculating the Q1, Q2 and Q3, however they can get slightly differing results because they use slightly different rules to calculate it, so just be aware. Alright, so question 2 here is to find the interquartile range, and this is fairly straightforward. So the formula to get this is you take the Q3 value and you take it away from, you take away from it the Q1 value. So substituting into this equation, Q3 we've already decided was 285. Q1 we decided was 271. So if you type this in a calculator, you end up with an answer of 14 days. So that's your interquartile range, and that answers part 2. So the last part here is identifying the outliers, and we've been told that outliers are going to be defined as observations more than 1.5 times the interquartile range below Q1 or above Q3. So if I move on here, I've recorded all those values that we just found, and I'm going to try and draw these out a bit more visually. So let me start off by drawing a line, and this is going to represent all the data that's in our spreadsheet for gestation times. And I'm going to mark a few points on it. So we know Q2 is at 279 days. We've got Q1 somewhere here at 271, and Q3 up here somewhere at 285 days. And the interquartile range that we calculated is this distance in here of 14 days. Now, we had a definition for our outlier, and that was that any values are an outlier if they're more than 1.5 times the interquartile range below Q1 or above Q3. So what we need to figure out is the point where we cross into those two areas. So let's start with the bottom one down here. Let me give it a name. I'm just going to call it, say, P low. And I'll call this one P high, and we'll calculate that in a moment. So we should be able to write ourselves an equation to figure out where that sits. So this bottom mark, we said that it's going to be below Q1. So if we start there, and it needs to be more than 1.5 times the interquartile range. So if we take away 1.5 IQR, all right, that's going to be where that point sits. So substituting in, Q1 we know is 271, and IQR, it's 14. So if you type that into a calculator, you end up finding that this is 250 days. So that's where that point sits. So what that means is if we have any values lower than it, they're going to be classed as outliers. Okay, so we can do the same thing on this end. Okay, so we know that this time, the point where we cross into outliers is above Q3, and it needs to be, again, 1.5 times the interquartile range bigger. So if we substitute in, it's 285, for Q3, plus 1.5 times the interquartile range we decided was 14. So this works out to 306 days. So that's where that sits. And again, anything above that now is going to be considered an outlier. And just to make this a little bit more visual, let me just mark in, this isn't quite to scale, but this distance in here should be 1.5 times the interquartile range, and so should this distance in here. Alright, so to finally answer this question, we just need to find the observations which are smaller than 250 days, so land in there, or larger than 306 days, so land in this upper portion. So jumping back, let's start with the 250. So these are sorted, which is convenient. So if we go all the way to the top, we're looking for anything smaller than 250, and we've got quite a lot. Alright, so all of these in here, let's give them a different color. These are all outliers. So that would be my answer for the bottom bit. So now the other ones were bigger than 306. So going back here, oh, we've only got a few on this end which are larger than 306. Okay, I'm not including 306 because it's right on the boundary. So that would be my final answer for this question. So these 3 points and all of these ones that I've highlighted here. So that's all there is for this video in terms of answering our questions, and I will see you in another one.